Hello and welcome to the November update from the Tau team. You're here with me, Fola. And without further ado, let's pass it over to Karim for his overview on the development team.
All right. Thank you, Fola. And welcome everybody to the November update for the development team. David has been continued his work on refactoring of the built-ins and the dictionary tables. He's cleaned up a lot of that code and fixed several bugs in it. And now he's working on some remaining issues as a result of the refactoring, simplifying the code, and wrapping up that implementation. He's also been helping Ohad with several mathematical questions relevant to the Tau language. Juan has been helping me personally with the TML documentation. He's written a very nice, almost like a textbook quality chapter on first order logic, complete with lots of examples of the kind of problems you can solve in first order logic. He's also continued testing of the TML implementation of non-pre-nex logical formulas. And he's also been testing our query answering capabilities that are also related to first order logic. Tomasz continued his work on the parser in cooperation with Umar. He's implemented an enhanced grammar that stores everything in disjunctive normal form. And this actually has allowed us to implement conjunction and negation of grammatical terms, which is a cool feature. It has also allowed us C++ programmers to have an easier way of defining grammars. He's also added eBNF support right into the parser. Luca continued his work on the 2CNF extraction feature. He's ran into a difficulty where he's got some cyclical graphs that he had to untangle. So he implemented an algorithm for removal of those loops in the graphs and removal of constant variables, and all working towards the canonical form of the transitive reduction of the 2CNF formulas. He's also been participating with Lewis on the MSO lectures with Ohad. Umar, also working on the parser with Tomasz, has implemented essentially another layer of graphs on top of the shared packed forest, and that allows those graphs to be acyclical and free of ambiguities. So they're much more useful at extracting parse trees as opposed to working directly on the shared packed forest, which would require a lot more work on the end users. So this makes it much easier to use the parser. It's also compatible with some of the optimization methods like binLR, and so that's for the parsing section. Andre has made a lot of progress on finalizing the testing of the Agoras Live application. He's fixed more than 20 issues this month that have been uncovered by our tester, and he's added and he made several improvements to the scheduling and notification systems in Agoras Live. That's it, and kick it back to Olas.
All right, fantastic. Thank you so much, Karim. And I'll pass it over to Andre for his update for the month.
Hello, everyone. So this month we finally finished testing our Agoras Live application. We uncovered more than 20 issues, I fixed them all, and also I did some improvements that we discussed to user experience of the Agoras Live. We added more notifications, more email notifications. Also, we added a separate page where you can list all public sessions and you can select categories of public sessions that you want to list. So next we will, of course, run the test again on Agoras Live to be sure that everything is smooth, but it won't take more than a week. And I hope next month we will be able to move to some close to public testing with our community. Thank you. See you next month.
All right, fantastic. Thanks so much, Andre. I'll pass it over to David now, so he can tell us what he's been up to this month.
Thank you, Fola. Hi, everyone. As Karin said, this month I have continued tweaking the refactoring of the TML source code, mostly regarding the dependencies between modules. More precisely, I've been refactoring the building of the built-ins into the dictionary, tables, and driver. This allows us to further segregate the different layers of the existing source code. Previously, the generation of the built-ins was placed in the tables constructor, and that requires from the dictionary and the ER builder. That was a problem. Now it's an independent object built using a built-in factory. That way we have clear boundaries between all the different modules, and we have a proper layered architecture in the source code. Apart from that, I have continued working in the refactoring, fixing issues, cleaning the source code, and trying to wrap all the implementation. And I have also, as Karim said, I've been working in several questions that OHAT has asked me about some mathematical issues regarding homomorphisms between rings and matrices equations. That's what I'm being up to. Thanks.
Thank you very much, David. I appreciate your update there. And I'll pass it over to Tomasz for his update next. Cheers, Tomasz.
Thank you, Fola. Hello, everyone. In November, I've continued to work on the parser. With the help of OHAT, I've implemented parser's grammar. In a way, it is stored as a disjunctive normal form, or DNF. And this new implementation allows to use conjunction and negation in production rules. And also it makes it easier to specify grammar right in C++ by using operators with literals. I've also updated the parser to work with the new grammar, and I've enhanced the parser to support the conjunction and negation as well. And I've spent some time trying to optimize eBNF support by moving it from grammar transformations to the parser, and currently I'm finishing grammar language or G language transformations into the new grammar structure. That's all from this month. Thanks.
All right, fantastic. Thank you so much, Tomasz. And I'll pass it over to Luca next, so you can tell us all about his month. Cheers.
Thank you, Fola. I've been continuing on the persistent canonical graph data structure that I've been advising over the last month. And in particular, I focused on implementing an online transitive reduction algorithm, also called a dynamic transitive reduction algorithm. And in addition to that, because the two CNFs we want to store not only in this data structure, but in a 3-split, the 2CNF implicational data structure is this persistent canonical graph data structure. And for this reason, this data structure also needs to be able to detect equality constraints that are added by implications, and they have the form of loops. For this reason, I also needed a loop extraction or a loop detection algorithm. And the third capability that this data structure needed was the extraction and detection of constant variables, which are created by inserting implications that cause contradictions when assign certain sets of variables, and so you can infer which variables are okay and which ones are not okay. For these algorithms to work, I needed to find a trick, and that's the technical issue Karim mentioned, how to expand the compressed graph, because the persistent canonical data structure is stored in a compressed form. But for graph traversal, this form needed to be expanded, and I have also figured out a solution on how to efficiently do this in order to enable proper path searches in this data structure. And that's it from me for this month. Thank you very much. And I'll pass it back to Fola.
All right, fantastic. Thank you so much, Luca. And I'll pass it over to Juan next for his update for the month.
Thank you, Fola. Hi, everybody. As usual, as Karim pointed out before, my main focus during this month has been to keep elaborating on our first-order logic feature. I put together several examples that could be used as a user guide. And I have been, of course, going deeper in our testing of our implementations of the solver with regards to properly handling non-parent-X normal form and structured formulas, both as in the in this SAT capability that our current solver has, and of course in the all satisfying assignment capability that it ends providing us a query answering with a semantic that could be defined as a disjunction of all satisfying assignments for a given formula. This, let's say, basic definition of our query answering language based on first order logic, this is not what at the end of the day TML provides in its full capability. Has been able to be defined in this way as part of our documentation and careful revision of the feature that is going on. So yeah, we need to reach to fully functional implementation of our solver. So we keep putting strong effort in testing and verifying all the different types of formulas that we can throw to it. So that's from my side for this month, and thank you.
Fantastic. Thank you so much, Juan. And now I'll pass it over to Umar for his update for the month.
Hi, team. Glad to share the update for this month. So in this month, most of the effort has been on extracting unambiguous graphs from the parse forest. Initial algorithms that we envisioned did not work, so we have to improve on them. Previously, we found some issues with the way the graphs and trees were being extracted, and we saw an issue. So while fixing those issues, we actually discovered a new way to extract these graphs with better data structures and having less recursive calls that simplified the code and solved the problem much elegantly than before. And also the extraction of graphs from the forest has now two variants. One is based on the unique nodes and the other is based on the unique edges, which means that in one variant you will not revisit the same node again, and in the another case you will not revisit the same edge again or twice. So the edge-based graph extraction actually exposes and discovers more parse trees than the node-based. Now we are able to extract these trees. They are stored in a vector of graphs, and the developer, the caller of this API, can actually enumerate and iterate over this vector and go over all possible trees that were hidden or present in the forest. Some of these graphs are just like trees, and they are unambiguous and readily applicable for further transformations. And some of these graphs will be actually having cycles and will not be able to reach the terminal, so they will not be useful. So it's up to the developer and the caller to differentiate here how to make use of these trees. Another suggestion that came from the lead was to rather than storing all the trees in one data structure, why not extract them one by one? So now we will be working on that feature so that graphs and trees that can be extracted from the forest could be done iteratively. Along with that, I've been testing these changes, making sure they work with the previous optimizations that we implemented, added new tests in the test parser, found some issues with the previous check-ins, shared with the respective dev, and we'll go ahead and check, make sure that everything seems to work as expected. So this month we have been able to achieve one of the long-standing feature, I would say, of our ability to extract trees and graphs out of the forest. Yeah, thank you.
All right, fantastic. Thank you so much, Umar. Really appreciate the update as always. And without further ado, and last but not least, I'll pass it over to Ahad for his update for the month.
And the main progress this month is in the Tau language, removing the need of some kind of ranking, some hierarchy of formulas, which is some syntactic restrictions that we wanted to get rid of and we managed, so things are much more smooth. And it also allows a much smooth integration in the future of other languages into the Tau language. So the Tau language can readily support many languages at once.
All right, fantastic. Thank you so much, Ahad. And thank you, all of you, for tuning in and asking us all the questions on the previous Q&As. And as always, we appreciate you and we'll see you on Telegram. Cheers. Thank you.